A watch is a small timepiece intended to be carried or worn by a person, so as to make the time immediately and conveniently available. It is designed to keep working despite the motions caused by the person's activities. A wristwatch is designed to be worn on a wrist, attached by a strap or other type of bracelet. A pocket watch is to be carried in a pocket. Watches evolved in the 17th century from spring-powered clocks, which appeared as early as the 15th century. The first watches were strictly mechanical, driven by clockwork. As technology progressed, mechanical devices, used to control the speed of the watch, were largely superseded by vibrating quartz crystals, producing accurately timed electronic pulses. The first digital electronic watch was developed in 1970. Most inexpensive and medium-priced watches, used mainly for timekeeping, are electronic watches with quartz movements. Expensive collectible watches, valued more for their elaborate craftsmanship, aesthetic appeal and glamorous design than for simple timekeeping, often have purely mechanical movements and are powered by springs, even though these movements are generally less accurate and more expensive than electronic ones. Various extra features, called complications, such as moon phase displays and the different types of tourbillon, are sometimes included. Modern watches often display the day, date, month and year, and electronic watches may have many other functions. Time-related features such as timers, chronographs and alarm functions are common. Some modern designs incorporate calculators, use GPS technology or have heart rate monitoring capabilities. Watches incorporating GPS receivers use them not only to determine their position. They also receive and use time signals from the satellites, which make them essentially perfectly accurate timekeepers, even over long periods of time. The study of timekeeping is known as horology. History. Watches evolved from portable spring-driven clocks, which first appeared in 15th century Europe. Watches weren't widely worn in pockets until the 17th century. One account says that the word watch came from the Old English word woex, which meant watchman, because it was used by town watchmen to keep track of their shifts at work. Another says that the term came from 17th century sailors, who used the new mechanisms to time the length of their shipboard watches. A great leap forward in accuracy occurred in 1657 with the addition of the balance spring to the balance wheel, an invention disputed both at the time and ever since between Robert Hooke and Christian Huygens. This innovation increased watches' accuracy enormously, reducing error from perhaps several hours per day to perhaps 10 minutes per day, resulting in the addition of the minute hand to the face from around 1680 in Britain and 1700 in France. The increased accuracy of the balance wheel focused attention on errors caused by other parts of the movement, igniting a two-century wave of watchmaking innovation. The first thing to be improved was the escapement. The verge escapement was replaced in quality watches by the cylinder escapement, invented by Thomas Tompion in 1695 and further developed by George Graham in the 1720s. Improvements in manufacturing such as the tooth-cutting machine devised by Robert Hooke allowed some increase in the volume of watch production, although finishing and assembling was still done by hand until well into the 19th century. A major cause of error in balance wheel timepieces, caused by changes in elasticity of the balance spring from temperature changes, was solved by the bimetallic temperature-compensated balance wheel invented in 1765 by Pierre Leroy and improved by Thomas Earnshaw. The lever escapement was the single most important technological breakthrough, and was invented by Thomas Mudge in 1759 and improved by Josiah Emery in 1785, although it only gradually came into use from about 1800 onwards, chiefly in Britain. The British had predominated in watch manufacture for much of the 17th and 18th centuries, but maintained a system of production that was geared towards high-quality products for the elite. Although there was an attempt to modernize clock manufacture with mass production techniques and the application of duplicating tools and machinery by the British Watch Company in 1843, it was in the United States that this system took off. Aram Lufkin Dennison started a factory in 1851 in Massachusetts that used interchangeable parts, and by 1861 was running a successful enterprise incorporated as the Waltham Watch Company. Wristwatch. The concept of the wristwatch goes back to the production of the very earliest watches in the 16th century. Elizabeth I of England received a wristwatch from Robert Dudley in 1571, described as an arm watch. From the beginning, wristwatches were almost exclusively worn by women, while men used pocket watches up until the early 20th century. Wristwatches were first worn by military men towards the end of the 19th century, when the importance of synchronizing maneuvers during war, without potentially revealing the plan to the enemy through signaling, was increasingly recognized. The Garstin Company of London patented a watch wristlet design in 1893, but they were probably producing similar designs from the 1880s. Officers in the British Army began using wristwatches during colonial military campaigns in the 1880s, such as during the Anglo-Burma War of 1885. During the Boer War, the importance of coordinating troop movements and synchronizing attacks against the highly mobile Boer insurgents became paramount, and the use of wristwatches subsequently became widespread among the officer class. The company Mappin and Webb began production of their successful campaign watch for soldiers during the campaign at the Sudan in 1898 and ramped up production for the Boer War a few years later. These early models were essentially standard pocket watches fitted to a leather strap, but, by the early 20th century, manufacturers began producing purpose-built wristwatches. The Swiss company, Tmier Frères & Cie, patented a wristwatch design with the now standard wire lugs in 1903. Hans Wilsdorf moved to London in 1905 and set up his own business with his brother-in-law Alfred Davis, Wilsdorf and Davis, providing quality timepieces at affordable prices. The company later became Rolex. Wilsdorf was an early convert to the wristwatch, and contracted the Swiss firm Aigler to produce a line of wristwatches. The impact of the First World War dramatically shifted public perceptions on the propriety of the man's wristwatch, and opened up a mass market in the post-war era. The creeping barrage artillery tactic, developed during the war, required precise synchronization between the artillery gunners and the infantry advancing behind the barrage. Service watches produced during the war were specially designed for the rigors of trench warfare, with luminous dials and unbreakable glass. The British War Department began issuing wristwatches to combatants from 1917. By the end of the war, almost all enlisted men wore a wristwatch, and after they were demobilized, the fashion soon caught on. The British Horological Journal wrote in 1917 that the wristlet watch was little used by the sterner sex before the war, but now is seen on the wrist of nearly every man in uniform and of many men in civilian attire. By 1930, the ratio of wrist to pocket watches was 50-1. The first successful self-winding system was invented by John Harwood in 1923. The introduction of the quartz watch in 1969 was a revolutionary improvement in watch technology. In place of a balance wheel which oscillated at 5 beats per second, it used a quartz crystal resonator which vibrated at 8,192 Hz, driven by a battery-powered oscillator circuit. Since the 1980s, more quartz watches than mechanical ones have been marketed. Movement. A movement of a watch is the mechanism that measures the passage of time and displays the current time. Movements may be entirely mechanical, entirely electronic, or they might be a blend of both. Most watches intended mainly for timekeeping today have electronic movements, with mechanical hands on the watch face indicating the time. Mechanical movements. Compared to electronic movements, mechanical watches are less accurate, often with errors of seconds per day, and they are sensitive to position, temperature and magnetism. They are also costly to produce, require regular maintenance and adjustments, and are more prone to failures. Nevertheless, the craftsmanship of mechanical watches still attracts interest from part of the watch-buying public, especially among the watch collectors. Skeleton watches are designed to leave the mechanism visible for aesthetic purposes. A mechanical movement uses an escapement mechanism to control and limit the unwinding and winding parts of a spring, converting what would otherwise be a simple unwinding into a controlled and periodic energy release. A mechanical movement also uses a balance wheel together with the balance spring to control motion of the gear system of a watch in a manner analogous to the pendulum of a pendulum clock. The tourbillon, an optional part for mechanical movements, is a rotating frame for the escape nut, which is used to cancel out or reduce the effects of gravitational bias to the timekeeping. Due to the complexity of designing a tourbillon, they are very expensive, and only found in prestigious watches. The pin lever escape nut, which is a cheaper version of the fully levered movement, was manufactured in huge quantities by many Swiss manufacturers as well as by Timex, until it was replaced by quartz movements. Tuning fork watches use a type of electromechanical movement. Introduced by Bulova in 1960, they use a tuning fork with a precise frequency to drive a mechanical watch. The task of converting electronically pulsed fork vibration into rotary movements is done via two tiny jeweled fingers, called pawls. Tuning fork watches were rendered obsolete when electronic quartz watches were developed. Quartz watches were cheaper to produce besides being more accurate. Traditional mechanical watch movements use a spiral spring called a mainspring as a power source. In manual watches the spring must be rewound periodically by the user by turning the watch crown. Antique Poquet watches were wound by inserting a separate key into a hole in the back of the watch and turning it. Most modern watches are designed to run 40 hours on a winding and thus must be wound daily, but some run for several days and a few have 192-hour mainsprings and are wound weekly. Automatic watches. A self-winding or automatic watch is one that rewinds the mainspring of a mechanical movement by the natural motions of the wearer's body. The first self-winding mechanism was invented for pocket watches in 1770 by Abraham Louis Perellet, but the first self-winding, or automatic, wristwatch was the invention of a British watch repairer named John Harwood in 1923. This type of watch winds itself without requiring any special action by the wearer. It uses an eccentric weight, called a winding rotor, which rotates with the movement of the wearer's wrist. The back-and-forth motion of the winding rotor couples to a ratchet to wind the mainspring automatically. Self-winding watches usually can also be wound manually to keep them running when not worn or if the wearer's wrist motions are inadequate to keep the watch wound. Electronic movements. Electronic movements, also known as quartz movements, have few or no moving parts, except a quartz crystal which is made to vibrate by the piezoelectric effect. A varying electric voltage is applied to the crystal, which responds by changing its shape so, in combination with some electronic components, it functions as an oscillator. It resonates at a specific highly stable frequency, which is used to accurately pace a timekeeping mechanism. Most quartz movements are primarily electronic but are geared to drive mechanical hands on the face of the watch in order to provide a traditional analog display of the time, a feature most consumers still prefer. In 1959 Seiko placed an order with Epson to start developing a quartz wristwatch. The project was codenamed 59A and by the 1964 Tokyo Summer Olympics, Seiko had a working prototype of a portable quartz watch which was used as the time measurements throughout the event. The first prototypes of an electronic quartz wristwatch were made by the CEH Research Laboratory in Neuchâtel, Switzerland. From 1965 through 1967 pioneering development work was done on a miniaturized 8192 Hz quartz oscillator, a thermocompensation module and an in-house made, dedicated integrated circuit. As a result, the BETA-1 prototype set new timekeeping performance records at the International Chronometric Competition held at the Observatory of Neuchâtel in 1967. The first quartz watch to enter production was the Seiko 35 SQ Astron, which hit the shelves on December 25, 1969. Thanks to the technology having been developed by the Swiss, Seiko could not patent the whole movement of the quartz wristwatch, thus allowing other manufacturers to participate in the rapid growth and development of the quartz watch market, thus ending in less than a decade of almost 100 years of dominance by the mechanical wristwatch legacy. The modern quartz movements are produced in very large quantities, and even the cheapest wristwatches typically have quartz movements. Whereas mechanical movements can typically be off by several seconds a day, an inexpensive quartz movement in a child's wristwatch may still be accurate to within half a second per day, Euro 10 times better than a mechanical movement. After a consolidation of the mechanical watch industry in Switzerland during the 1970s, Mass production of quartz wristwatches took off under the leadership of the Swatch Group of companies, a Swiss conglomerate with vertical control of the production of Swiss watches and related products. For quartz wristwatches, subsidiaries of Swatch manufacture watch batteries, oscillators and integrated circuits. The launch of the new Swatch brand in 1983 was marked by bold new styling, design and marketing. Today, the Swatch Group maintains its position as the world's largest watch company. Seiko's efforts to combine the quartz and mechanical movements bore fruit after 20 years of research, leading to the introduction of the Seiko Spring Drive, first in a limited domestic market production in 1999 and to the world in September 2005. The Spring Drive manages to keep time within quartz standards without the use of a battery, using a traditional mechanical gear train powered by a spring, while at the same time doesn't have the need of a balance wheel either. Radio time signal watches are a type of electronic quartz watch which synchronizes its time with an external time source such as in atomic clocks, time signals from GPS navigation satellites, the German DCF-77 signal in Europe, WWVB in the US, and others. Movements of this type may among others synchronize not only the time of day but also the date, the leap year status of the current year, and the current state of daylight saving time. However, other than the radio receiver, these watches are normal quartz watches in all other aspects. Electronic watches require electricity as a power source, and some mechanical movements and hybrid electronic mechanical movements also require electricity. Usually the electricity is provided by a replaceable battery. The first use of electrical power in watches was as a substitute for the mainspring, in order to remove the need for winding. The first electrically powered watch, the Hamilton Electric 500, was released in 1957 by the Hamilton Watch Company of Lancaster, Pennsylvania. Watch batteries are specially designed for their purpose. They are very small and provide tiny amounts of power continuously for very long periods. In most cases, replacing the battery requires a trip to a watch repair shop or watch dealer. This is especially true for watches that are designed to be water-resistant, as special tools and procedures are required to ensure that the watch remains water-resistant after battery replacement. Silver oxide and lithium batteries are popular today. Mercury batteries, formerly quite common, are no longer used, for environmental reasons. Cheap batteries may be alkaline, of the same size as silver oxide cells but providing shorter life. Rechargeable batteries are used in some solar-powered watches. Some electronic watches are also powered by the movement of the wearer of the watch. For instance, Seiko's kinetic-powered quartz watches make use of the motion of the wearer's arm turning a rotating weight which causes a tiny generator to supply power to charge a rechargeable battery that runs the watch. The concept is similar to that of self-winding spring movements, except that electrical power is generated instead of mechanical spring tension. Solar-powered watches are powered by light. A photovoltaic cell on the face of the watch converts light to electricity, which in turn is used to charge a rechargeable battery or capacitor. The movement of the watch draws its power from the rechargeable battery or capacitor. As long as the watch is regularly exposed to fairly strong light, it never needs battery replacement, and some models need only a few minutes of sunlight to provide weeks of energy. Some of the early solar watches of the 1970s had innovative and unique designs to accommodate the array of solar cells needed to power them. As the decades progressed and the efficiency of the solar cells increased while the power requirements of the movement and display decreased, solar watches began to be designed to look like other conventional watches. A rarely used power source is the temperature difference between the wearer's arm and the surrounding environment. Display, analog. Traditionally, watches have displayed the time in analog form, with a number dial upon which are mounted at least a rotating hour hand and a longer, rotating minute hand. Many watches also incorporate a third hand that shows the current second of the current minute. Watches powered by quartz usually have a second hand that snaps every second to the next marker. Watches powered by a mechanical movement appears to have a gliding second hand, although it is actually not gliding. The hand merely moves in smaller steps, typically 1/5 of a second, corresponding to the beat of the balance wheel. In some escapements, the hand advances every 2 beats of the balance wheel, typically 1/2 second in those watches, or even every 4 beats, in the double duplex escapement. A truly gliding second hand is achieved with the tri-synchro regulator of spring drive watches. All of the hands are normally mechanical, physically rotating on the dial, although a few watches have been produced with hands that are simulated by a liquid crystal display. Analog display of the time is nearly universal in watches sold as jewelry or collectibles, and in these watches, the range of different styles of hands, numbers, and other aspects of the analog dial is very broad. In watches sold for timekeeping, analog display remains very popular, as many people find it easier to read than digital display. But in timekeeping watches the emphasis is on clarity and accurate reading of the time under all conditions. They are specifically designed for the left wrist with a stem on the right side of the watch. This makes it easy to change the time without removing the watch from the wrist. This is the case if one is right-handed and the watch is worn on the left wrist. If one is left-handed and wears the watch on the right wrist, one has to remove the watch from the wrist to reset the time or to win the watch. Analog watches as well as clocks are often marketed showing a display time of approximately 1:50 or 10:10. This creates a visually pleasing smile-like face on the upper half of the watch, in addition to enclosing the manufacturer's name. Digital displays often show a time of 12:08, where the increase in the number of active segments or pixels gives a positive feeling. Tactile, Tissot, a Swiss luxury watchmaker, makes the Sound T wristwatch with a touch-sensitive face that vibrates to help the user to tell time eyes-free. The bezel of the watch features raised bumps at each hour maker. After briefly touching the face of the watch, the wearer runs a finger around the bezel clockwise. When the finger reaches the bump indicating the hour, the watch vibrates continuously, and when the finger reaches the bump indicating the minute, the watch vibrates intermittently. One Timepieces, Washington, D.C.-based company, launched its first tactile analog wristwatch, the Bradley, on July 11, 2013 on the Kickstarter website. The device is primarily designed for sight-impaired users, who can use the watch's 2 ball bearings to determine the time, but it is also suitable for general use. The watch features raised marks at each hour and 2 moving, magnetically attached ball bearings. One ball bearing, on the edge of the watch, indicates the hour, while the other, on the face, indicates the minute. Digital. A digital display simply shows the time as a number, for example, 12:08 instead of a shorthand pointing towards the number 12 and a longhand 8/60ths of the way round the dial. The digits are usually shown as a 7-segment display. The first digital mechanical pocket watches appeared in late 19th century. In the 1920s, the first digital mechanical wristwatches appeared. The first digital electronic watch, a pulsar LED prototype in 1970, was developed jointly by Hamilton Watch Company and Electrodata, founded by George H. Thies. John Berge, the head of Hamilton's Pulsar division, said that he was inspired to make a digital timepiece by the then futuristic digital clock that Hamilton themselves made for the 1968 science fiction film 2001, A Space Odyssey. On April 4, 1972, the Pulsar was finally ready, made in 18-karat gold and sold for $2,100. It had a red light-emitting diode display. Digital LED watches were very expensive and out of reach to the common consumer until 1975, when Texas Instruments started to mass-produce LED watches inside a plastic case. These watches, which first retailed for only $20, reduced to $10 in 1976, saw Pulsar lose $6 a million and the Pulsar brand sold to Seiko. An early LED watch that was rather problematic was the black watch made and sold by British company Sinclair Research in 1975. This was only sold for a few years, as production problems and return product forced the company to cease production. Most watches with LED displays required that the user press a button to see the time displayed for a few seconds, because LEDs used so much power that they could not be kept operating continuously. Usually the LED display color would be red. Watches with LED displays were popular for a few years, but soon the LED displays were superseded by liquid crystal displays, which used less battery power and were much more convenient in use, with the display always visible and no need to push a button before seeing the time. Only in darkness you had to press a button to light the display with a tiny light bulb, later illuminating LEDs. The first LCD watch with a 6-digit LCD was the 1973 Seiko 06LC, although various forms of early LCD watches with a 4-digit display were marketed as early as 1972, including the 1972 Gruen Teltime LCD watch, and the Cox Electronic Systems Quartz. In Switzerland, a Bourge's Electronic SA presented a prototype 8-digit LCD wristwatch showing time and date at the MUBA Fair, Basel, in March 1973, using a twisted pneumatic LCD manufactured by Braun, Bavarian C., Switzerland, which became the supplier of LCDs to Casio for the Casio-Tron watch in 1974. A problem with liquid crystal displays is that they use polarized light. If, for example, the user is wearing polarized sunglasses, the watch may be difficult to read because the plane of polarization of the display is roughly perpendicular to that of the glasses. If the light that illuminates the display is polarized, for example if it comes from a blue sky, the display may be difficult or impossible to read. From the 1980s onward, digital watch technology vastly improved. In 1982 Seiko produced the Seiko TV watch that had a television screen built in, and Casio produced a digital watch with a thermometer as well as another that could translate 1,500 Japanese words into English. In 1985, Casio produced the CFX 400 scientific calculator watch. In 1987 Casio produced a watch that could dial your telephone number, and Citizen revealed one that would react to your voice. In 1995 Timex released a watch which allowed the wearer to download and store data from a computer to their wrist. Some watches, such as the Timex DataLink USB, feature dot matrix displays. Since their apex during the late 1980s to mid-1990s high-technology fad, digital watches have mostly become simpler, less expensive timepieces with little variety between models. Despite these many advances, almost all watches with digital displays are used as timekeeping watches. Expensive watches for collectors rarely have digital displays since there is little demand for them. Less craftsmanship is required to make a digital watch face, and most collectors find that analog dials vary in quality more than digital dials due to the details and finishing of the parts that make up the dial, thus making the differences between a cheap and expensive analog watch more evident. Illuminated. Many watches have displays that are illuminated, so they can be used in darkness. Various methods have been used to achieve this. Mechanical watches often have luminous paint on their hands and hour marks. In the mid-20th century, radioactive material was often incorporated in the paint, so it would continue to glow without any exposure to light. Radium was often used, but produced small amounts of radiation outside the watch which might have been hazardous. Tritium was used as a replacement, since the radiation it produces has such low energy that it cannot penetrate a watch glass. However, tritium is expensive, since it has to be made in a nuclear reactor, and it has a half-life of only about 12 years, so the paint does not remain luminous for more than a few years. Nowadays, tritium is still used in specialized watches, for example for military purposes. For other purposes, luminous paint is still sometimes used on analog displays, but no radioactive material is contained in it. This means that the display glows soon after being exposed to light, but quickly fades. Watches that incorporate batteries often have electric illumination of their displays. However, lights consume far more power than electronic watch movements. In order to conserve the battery, the light is activated only when the user presses a button. Usually, the light remains lit for a few seconds after the button is released, which allows the user to move the hand out of the way. In some early digital watches, LED displays were used, which could be read as easily in darkness as in daylight. However, the user had to press a button to light up the LEDs, which meant that the watch could not be read at all without the button being pressed, even in full daylight. In some cheaper types of watch, Small incandescent lamps or LEDs are used to illuminate the display, which is not intrinsically luminous. However, these tend to produce very non-uniform illumination. Incandescent lamps are also very wasteful of electricity. Other watches use electroluminescent material to produce uniform illumination of the background of the display, against which the hands or digits can be seen. Handedness. Wristwatches with analog displays generally have a small knob, called the crown, that can be used to adjust the time and, in mechanical watches, wind the spring. Almost always, the crown is located on the right-hand side of the watch. This makes it inconvenient to use if the watch is being worn on the right wrist. Usually, therefore, watches are worn on the left wrist, even if the wearer is left-handed. In exceptional cases, the crown is on the left side of the watch. This is, for example, to prevent it from digging into the wrists of golf players. Digital watches generally have push buttons that can be used to make adjustments. These are usually equally easy to use on either wrist. Functions. All watches provide the time of day, giving at least the hour and minute, and usually the second. Most also provide the current date, and often the day of the week as well. However, many watches also provide a great deal of information beyond the basics of time and date. Some watches include alarms. Other elaborate and more expensive watches, both pocket and wrist models, also incorporate striking mechanisms or repeater functions, so that the wearer could learn the time by the sound emanating from the watch. This announcement or striking feature is an essential characteristic of true clocks and distinguishes such watches from ordinary timepieces. This feature is available on most digital watches. A complicated watch has one or more functions beyond the basic function of displaying the time and the date. Such a functionality is called a complication. Two popular complications are the chronograph complication, which is the ability of the watch movement to function as a stopwatch, and the moon phase complication, which is a display of the lunar phase. Other more expensive complications include tourbillon, perpetual calendar, minute repeater, and equation of time. A truly complicated watch has many of these complications at once. Some watches can both indicate the direction of Mecca and have alarms that can be set for all daily prayer requirements. Among watch enthusiasts, complicated watches are especially collectible. Some watches include a second 12-hour or 24-hour display for UTC or GMT. The similar-sounding terms chronograph and chronometer are often confused, although they mean altogether different things. A chronograph has a stopwatch complication, as explained above, while a chronometer watch has a high-quality mechanical or a thermo-compensated movement that has been tested and certified to operate within a certain standard of accuracy by the COSC. The concepts are different but not mutually exclusive. So a watch can be a chronograph, a chronometer, both, or neither. Many computerized wristwatches have been developed, but none have had long-term sales success, because they have awkward user interfaces due to the tiny screens and buttons, and a short battery life. As miniaturized electronics became cheaper, watches have been developed containing calculators, dynamometers, barometers, altimeters, a compass using both hands to show the NS direction, video games, digital cameras, Ki drives, GPS receivers and cellular phones. A few astronomical watches show phase of the moon and other celestial phenomena. In the early 1980s Seiko marketed a watch with a television in it. Such watches have also had the reputation as unsightly and thus mainly geek toys. Several companies have however attempted to develop a computer contained in a wristwatch. Electronic sports watches, combining timekeeping with GPS and/or activity tracking, address the general fitness market and have the potential for commercial success. Braille watches have analog displays with raised bumps around the face to allow blind users to tell the time. Their digital equivalents use synthesized speech to speak the time on command. Uses, fashion. Wristwatches and antique pocket watches are often appreciated as jewelry or as collectible works of art rather than just as timepieces. This has created several different markets for wristwatches, ranging from very inexpensive but accurate watches to extremely expensive watches that serve mainly as personal adornment or as examples of high achievement in miniaturization and precision mechanical engineering. Traditionally, men's dress watches appropriate for informal, semi-formal, and formal attire are gold, thin, simple, and plain, but increasingly rugged, complicated, or sports watches are considered by some to be acceptable for such attire. Some dress watches have a cabochon on the crown and many women's dress watches have faceted gemstones on the face, bezel, or bracelet. Some are made entirely of faceted sapphire. Many fashion and department stores offer a variety of less expensive, trendy, costume watches, many of which are similar in quality to basic quartz timepieces but which feature bolder designs. In the 1980s, the Swiss Swatch Company hired graphic designers to redesign a new annual collection of non-repairable watches. Trade in counterfeit watches, which mimic expensive brand name watches, constitutes an estimated $1 billion market per year. Space. Zero-gravity environment and other extreme conditions encountered by astronauts in space requires the use of specially tested watches. On April 12, 1961, Yuri Gagarin wore a Sturmansky wristwatch during his historic first flight into space. The Sturmansky was manufactured at the first Moscow factory. Since 1964, the watches of the first Moscow factory have been marked by the trademark €OE3/4th and a euro, transliterated as a euro polja to euro, which means a euro flight to euro in Russian and is a tribute to the many space trips its watches have accomplished. In the late 1970s, Poljot launched a new chrono movement, the 3133. With a 23 dual movement and manual winding, it was a modified Russian version of the Swiss Valjoux 7734 of the early 1970s. Poljot 3133 were taken into space by astronauts from Russia, France, Germany and Ukraine. On the arm of Valery Polyakov, a Poljot 3133 chronograph movement-based watch set a space record for the longest space flight in history. Through the 1960s, a large range of watches were tested for durability and precision under extreme temperature changes and vibrations. The Omega Speedmaster Professional was selected by NASA, the U.S. space agency. Her became the first Swiss watch in space thanks to a Hostop watch, worn by John Glenn in 1962 when he piloted the Friendship 7 on the first manned U.S. orbital mission. The Breitling Navitimer cosmonaut was designed with a 24-hour analog dial to avoid confusion between AM and PM, which are meaningless in space. It was first worn in space by U.S. astronaut Scott Carpenter on May 24, 1962 in the Aurora 7 Mercury capsule. Since 1994, Fortis is the exclusive supplier for manned space missions authorized by the Russian Federal Space Agency. China National Space Administration astronauts wear the Further space watches. At Basel World, 2008, Seiko announced the creation of the first watch ever designed specifically for a spacewalk, Spring Drive Spacewalk. Timex Datalink is flight certified by NASA for space missions and is one of the watches qualified by NASA for space travel. The Casio G-Shock DW5600C and 5600E, DW6900, and DW5900 are flight qualified for NASA space travel. Various Timex Datalink models were used both by cosmonauts and astronauts. Scuba diving. Watches may be crafted to become water-resistant. These watches are sometimes called diving watches when they are suitable for scuba diving or saturation diving. The International Organization for Standardization issued a standard for water-resistant watches which also prohibits the term waterproof to be used with watches, which many countries have adopted. Water resistance is achieved by the gaskets which forms a watertight seal, used in conjunction with a sealant applied on the case to help keep water out. The material of the case must also be tested in order to pass as water-resistant. None of the tests defined by ISO 2281 for the water-resistant mark are suitable to qualify a watch for scuba diving. Such watches are designed for everyday life and must be water-resistant during exercises such as swimming. They can be worn in different temperature and pressure conditions but are under no circumstances designed for scuba diving. The standards for diving watches are regulated by the ISO 6425 International Standard. The watches are tested in static or still water under 125% of the rated pressure, thus a watch with a 200-meter rating will be water-resistant if it is stationary and under 250 meters of static water. The testing of the water resistance is fundamentally different from non-dive watches, because every watch has to be fully tested. Besides water resistance standards to a minimum of 100-meter depth rating, ISO 6425 also provides 8 minimum requirements for mechanical divers' watches for scuba diving. For divers' watches for mixed gas saturation diving, 2 additional requirements have to be met. Watches are classified by their degree of water resistance, which roughly translates to the following: some watches use bar instead of meters, which may then be multiplied by 10, and then subtract 10 to be approximately equal to the rating based on meters. Therefore, a 5-bar watch is equivalent to a 40-meter watch. Some watches are rated in atmospheres, which are roughly equivalent to bar. Using a watch in the sun is a compass. An analog watch can be used to locate north and south. The sun appears to move in the sky over a 24-hour period, while the hour hand of a 12-hour clock face takes 12 hours to complete one rotation. In the northern hemisphere, if the watch is rotated so that the hour hand points toward the sun, the point halfway between the hour hand and 12 o'clock will indicate south. For this method to work in the southern hemisphere, the 12 is pointed towards the sun and the point halfway between the hour hand and 12 o'clock will indicate north. During daylight saving time, the same method can be employed using 1 o'clock instead of 12. This method assumes that the azimuth of the sun changes at a constant rate throughout the day. Strictly, this is true only if the observer is at one of the Earth's poles. Close to the equator, the sun's azimuth changes at very different speeds at different times of day, and even sometimes reverses direction. In an extreme case, seen from the equator at an equinox, the sun appears to rise vertically from the eastern horizon to the zenith, so for several hours its azimuth does not change. The sun is due east all morning. Then, as it appears to pass directly overhead at noon, its azimuth abruptly changes by 180 degrees, from due east to due west. Following that, the sun appears to descend vertically, at a constant azimuth of due west, to the western horizon. As seen from other places at fairly low latitudes, and on different dates, the rate of change of the solar azimuth also varies during the day, but to a less extreme extent. This completely invalidates this method of using a watch as a compass in tropical and low-temperate latitudes. However, at fairly high latitudes, more than about 50 degrees north or south, the speed of the sun's change of azimuth is sufficiently constant to allow the method to be accurate enough for simple purposes. See also, American Watchmakers Clockmakers Institute, Coin Watch, List of watch manufacturers, Marine Chronometer, National Association of Watch and Clock Collectors, Smartwatch, Solar-Powered Watch, Tachymeter, Watch Time Magazine, Wristwatch Computer, References. Notes. Further reading, Beckett, Edmund, A Rudimentary Treatise on Clocks, Watches and Bells, 1903, from Project Gutenberg, Berner, G.A., Illustrated Professional Dictionary of Horology, Federation of the Swiss Watch Industry FH 1961 Euro 2012, Daniels, George, Watchmaking, London, Philip Wilson Publishers, 1981, de Carl, Donald Practical Watch Repairing, 3rd edition, New Yorker Skyhorse Pub, 2008. ISBN 978-1-60239-357-8. Significant information on watches, their history, and inner workings. Den, Mark, The Tourbillon and How It Works, IEEE Control Systems Magazine, June 2010, IEEE Control Systems Society, DOI 10.1109/MCS. 2010.936291. Grafton, Edward, Horology, A Popular Sketch of Clock and Watchmaking, London, Aylett and Jones, 1849, external links, Philadelphia Exhibition 1876 Report to the Federal High Council by ed. Favre Perrott, American and Swiss watchmaking in 1876 by Jacques David, The Watch Factories of America Past and Present by Henry G. Abbott, Watchmaking and the American System of Manufacturing, Federation of the Swiss Watch Industry FH, UK Patent GB 218487, Improvements relating to wristwatches, 1923 patent resulting from John Harwood's invention of a practical self-winding watch mechanism. The most expensive watches,